your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Jim Hutchinson, co-founder and CEO of Fusion Processing. On today's episode, we'll discuss how Fusion Processing is developing and deploying SAE Level 4 autonomous buses. We hope you enjoy this episode. Jim, welcome to the podcast.
Hi, thank you. It's great to be here.
It's great to have you here, Jim. This is a first for us. This is the first time we ever done an episode on autonomous buses. I'm really geeked out for it. I've been studying the industry in preparation for our podcast today. So you co-founded Fusion Processing. Why are you so laser focused developing autonomous driver systems for commercial vehicles with a particular interest in buses?
Yeah, it's a good question. I think when we first started the company, we were looking at how best to apply the technology and how we could commercialize it. How we could actually turn it into a good business that we could fund and we could work. And it really came down to looking at the economics and where we thought the technology could be commercialized first. And when we look at the commercial vehicle space, there are just such clear advantages to using autonomous vehicles over manual drive that we felt that was definitely the way we had to focus. So really that sort of focus on the commercial on both passenger and freight that came very early on in our journey. I think really the buses really came from specific opportunities which arose. So having sort of decided that's really the segments we're going to look at. The major focus on buses really came from a need within our sort of country within the UK to actually do this, and but also willing partners, and that's another key necessity is that we've got willing vehicle manufacturers who want to partner with us and get in there early, and operators, and they've been key, and they've been great for getting this going and getting it to where it is.
When you initially saw the opportunities, commercial vehicles is well documented. It's a very lucrative field for autonomy, but zoning in on buses, was it in the public sector? Was it in the private sector? Where did you initially see those opportunities?
Well, I think it's in both, and certainly we're seeing a lot of interest in both areas. So we haven't really sort of decided to we'll only look at public sector. There's sort of use cases that are both in privately managed areas and regions. So we've got a lot of interest in airports and those sort of places, but also in those public services, and a lot of regions are sort of very interested in how they can use this technology and really improve the services they're offering.
On airports, in April, you announced a partnership with Construct Invest to deploy the autonomous buses at airports. Are these going to be on tarmac? Will they be behind the gate? Where will they be deployed for airports?
Well, it's looking at both sides of things, really, because I think there's a definite benefit to using autonomous buses for example, for terminal-to-terminal transfers. So if you're looking at moving lots and lots of people between 2 points, and you might want to put in a rail system, but this is hugely expensive. It's the costs of doing that are colossal, and the downside really is then also that you've got something that's really quite inflexible. If you then want to change it or want to expand it, it's much more difficult. Whereas the system that we proposed, we give all the same benefits in terms of safety and usability, and it can scale, and it can scale to get the same sort of passenger throughput, and it's much more flexible. So when it needs to be adapted, when it needs to be expanded, it can do that much more easily, and it's it's a fraction of the cost of implementing the rail. So that's the one side. We see that as a really big opportunity for us, but also for the airports. And then, of course, there's the other sort of more obvious side, which is, the car park, the buses which are taking people from the car parks to the terminals, and that's perhaps much sort of established as a bus use case, but we can certainly automate that and make things more efficient.
One of the big advantages, if you look at it from building rail, construction causes traffic. It shuts down lanes, and passengers are stressed out, they're aggravated, and just adds that your buses, you as the demand goes, if it's during the holidays, you can add more buses, and it's very flexible. Do you see those operating on fixed routes, say going from terminal A, B, and C, and then as you mentioned, the car parts? Okay, so from terminal C to terminal B, then to car park, and it's kind of basically going on these circular loops, but being able to add more buses based on seasonal demand on the airport has that data?
Yeah, that's right. The benefit is the whole economics of the operation changes a bit. So, it may be preferable to run more smaller vehicles at certain times. And we've got, also the option of running them more as an on-demand service. Again, there's lots of efficiencies that you can make once you've got the system running. There's all sorts of optimizations that can be made there. And it isn't a one size fits all. There are some which will want to just carry on with very much like a fixed route operation. And that's fine. And, in a lot of cases, that is the best way of doing things. But as I say, there's probably a lot more options in terms of the managing of that passenger throughput. And as I say, perhaps the use of smaller vehicles in times when there's less demand.
So if you look at Heathrow, do you see these probably being deployed in Manchester? Do you see them being deployed in Heathrow, or some of the smaller regional airports throughout the country, even going into Wales, for example? How do you just see them being deployed?
Yeah, I mean, so we're seeing interest at both ends of the scale, actually. I think, we've been talking recently to one of the biggest airports in the world, actually. And so we're looking internationally as well, I should say. We're talking to airports internationally, not just in the UK. So, but also, we've also got interest from one of the smaller operations, they've just got, a single small terminal, and it's offering a key service and actually flying internationally as well. So, we're seeing both ends of the scale, because I think in both of those scenarios, there's a lot to be gained from use of autonomous vehicles, particularly when you think about how you can link that up to the other needs, the sort of the needs on the freight side as well. And I think once people are comfortable with one, they're more likely to adopt the other. So we've got an interest in both sides, not just from our own system and our own vehicles, but we are also happy to work with other players in this space. We're not against working with other people who have good autonomous technology.
The partnership is what's going to make this scale. And if you're an airport, most of the airports are owned by a government entity, and they have to get competitive bids. And a lot of the times, historically, those are joint projects where, okay, you're a great engineer, you're a great planner. Okay, let's come together and do this for the benefit of the taxpayers. Let's say you close an airport contract. Let's call it Acme Airport. You close the contract, you sign it, and they say, okay, Jim, ready to go. What do you need to do? Do you have to build a charging infrastructure? Do you have to build a terminal? What do you have to do from the time that contract's signed to the time you get it up and operating?
Yeah, I mean, so it really depends on what it is that they have already and what it is they need. So, for example, if they're already running electric buses, then that's a lot of that charging infrastructure is already in place. If it's a simple, we're just replacing an existing service, say it could be a car park service, then again, there's not too much setup. There's all the safety aspects to go through and approvals and those sorts of things, and then some route setup and testing. But generally speaking, it's not such a big deal. On the other hand, if actually what we're doing is working with the customer to implement something which is completely new, something like the terminal to terminal, then we would ideally be in there at the planning phase, so we can make sure they fully understand, the best way of operating the autonomous vehicles, and if the infrastructure is done that in mind right from the start, then it can work really well.
Airports are clearly a growth market for autonomous buses. A couple of months ago, in Portugal, hosted an autonomous vehicle conference for airports, which was pretty impressive. And so the demands there, and as you clearly rightfully said, it's not just the UK, it's a global phenomenon of these airports authorities that are looking to deploy autonomy there. So airports, clear market for growth. Outside of airports, what other markets are you seeing for growth for autonomous buses?
Yeah, so within buses, I mean, it's across the board, because on the one hand, we've got, not just in the UK, but in a lot of countries, where there's driver shortages. And so there aren't as many services running. And increasingly, we're seeing perhaps a lack of services because they're not commercially viable. And I think, if we can run autonomous buses on some of those routes, then again, I think there's a lot more possibilities in terms of running more services. And again, that, just helps people to be more mobile, get around more easily, and maybe encourage, people to use more sustainable ways of travel rather, resorting to jumping in personal cars. But also, again, we've done a lot of work on the interurban routes and the longer distance routes. And again, they all sort of suffer from the pressure of finding enough drivers to run the services, and that is increasingly a problem. So again, it can mean that services which could run don't. But then also in cities as well, right from the biggest cities, such as London, there is an interest in automation. I don't think they're going to be going to sort of fully autonomous just yet, but there's certainly interest in the technology and what it can do for safety. And again, that aspect, I can't emphasize enough really that, that's another key driver for autonomous buses, is that, they can be made safer, and we can really make some big improvements there too.
I want to highlight for the audience that the UK is very bullish on autonomy. There's an interview that was published in the BBC this week that Parliament is looking at 2027 for fully autonomous vehicles. The UK is putting a framework to allow technology such as yours and the whole industry to thrive in the United Kingdom. You talked about services. In America, we have a service called Dial-A-Ride that will take an elderly individual from the senior center to a doctor or to dialysis, wherever they want. And unfortunately, as you clearly stated, it's the same thing here in America. There's driver shortage, and some of those elderly individuals, they can't drive, and because the Dial-A-Ride, they have to wait weeks to get a doctor's appointment, which frankly is unfair. Do you see an opportunity where, say, a smaller form factor of autonomous bus could take 2 or 3 senior citizens to the doctors without having to worry, well, you have to wait 3 weeks because there's a driver not available?
Yeah, absolutely. I mean, that is another use case that we've considered. I mean, we also do electric minibuses, which have been used on, well, 1 or 2 projects, one that's running currently, and they're very useful in those sorts of scenarios where you've got that need for an on-demand service. And yeah, I mean, it's potentially a really efficient way of running these things, and we would hope can work really well for the people that really need to use them, like you described.
The different form factors of the vehicles, the van versus a traditional bus. Does the driving stack change from a technology standpoint? Does it change where you put the sensors, or you're taking your traditional fusion processing autonomy stack and then just adapting it to the different form factors?
Yeah, well, I think that was really a requirement on our system that we sort of specified right from the word go, that this had to be a very scalable system. That we weren't entirely sure at the start, where we would see the initial successes, commercial successes. So it was really important that we had a system which could be configured for really very large vehicles like full-size buses, but right down to very small vehicles like the tow tractors that we also do. And essentially, at the heart of it is the same system that we use. But essentially, we can omit certain features, which makes it smaller and more efficient, and it's very flexible as to the sensors that the system utilizes. So it's very configurable in that sense. So yeah, essentially it's really different configurations of the same system that we use.
So to me, that says highly scalable. Your system's highly scalable.
Absolutely, yeah. That was, as I say, that was a key requirement for the design initially.
You have a highly scalable system that's capable of doing a variety of commercial vehicles. The next element is weather. We can't control it. It'd be cool if we could, but we can't control it. Are there any weather restrictions at the moment where your technology can and cannot operate?
Yeah, so we've had a lot of experience. For anyone that knows the region and particularly Scotland, yeah, the weather can be very, very changeable, and we've got a lot of experience with that now. So the system's getting better all the time, and there are limits, but the system can adapt itself, and even in heavy rain, it can run, albeit it has to run a bit slower. It will adapt to in the same way that a careful human driver would adapt the way they drive to the conditions. The system has to do the same to some degree. There are still limits, and we hope to be removing those over time. We've got new sensors coming along within the next 12 months as well, which will increase the sort of the tolerance to those sort of really heavy showers and heavy downpours that are and for some regions it's really important because they can be at times of the year a daily event. So this is important that the systems can cope with those. And I mean, it is quite, as I say, over the course of the time period that we were running the Cav Fourth project for, we did manage to get quite a high level of resilience towards the sort of the inclement weather.
Based on where you are, it's a fair assumption you've mastered rain. Until London rain it's a fair assumption. But the question is, it'd be really cool. I know they don't make it, but if they made wellies for the sensors, that would be really cool. You could take it to a whole different level.
Yeah, you should. Yeah, you should patent that one. That's a good one. I like that.
I own a pair of wellies and I love them, and I wear them when it rains, and they're wonderful. Now, from wellies to technology, I want to talk about a deployment that you had here. In May 2023, Fusion Processing, you were part of a group that deployed 5 autonomous buses. That's impressive. I want to highlight that. 5 autonomous buses as part of the CAV Fourth project. Project lasted 2 years. What did you learn during that deployment?
I think, I mean, that was hugely valuable. I think that we learned in a number of areas, really. I think so. Firstly, as we've already touched on, that when you're running 7 days a week, 10 and 12 hours a day with a continuous service that's going on. The service ran on motorway, it ran on smaller roads as well, and ran some sort of more pedestrian pieces. And you pick up things and learn more than you can just by modeling and simulation and things like that. I guess there's things happen that perhaps just wouldn't be envisaged. So there's a lot of learning there. But I think equally valuable to all of that is actually, it really enabled us to hone the sort of the depot and maintenance processes for our autonomous vehicles and really make sure that they work well for the operator. And that was done in conjunction with the operator for this. So it was very much a two-way process. We weren't sort of trying to fit in very much with the way they would normally run a depot and make sure that running autonomous vehicles doesn't become burdensome to them. So I think there's a huge amount of learning that we got from that, to the point where it is now much easier for us to do similar setup, pretty much anywhere, to be honest. It's, we do see a lot of commonality in any case between, not just within Europe, but across the world. So, it's really set us up nicely to be able to deploy pretty much anywhere.
When you develop the maintenance, you develop a playbook and says, okay, they come in the morning after the 12-hour shift, you do the walkthrough, you can essentially kick the tires and you have a checklist. Did you develop a playbook that was able to say every day, okay, same thing, it's like clockwork, everybody knew?
Yeah, and that's right. This is we have sort of recommended procedures, and obviously to some extent these procedures in some areas are, this is what needs to be done, and in other areas it can be adapted for the particular environment and the operator and their use case and their own working practices. So there is some flexibility in that. So we aim to make it so that it's easy for people to pick up this technology and use it.
But I want to highlight the aspect of it. So you have the maintenance, you work with the operator, you're creating jobs because you're teaching a new skill. Cleaning sensors, launching, you're creating jobs and creating skills, which is a really important thing here to highlight. For that project, you worked with Stagecoach from day one. How did you integrate your autonomous driving stack into the Stagecoach bus?
Yeah, so the buses for that project were provided by Alexander Dennis, who's an OEM partner of ours. We work very closely with them. They've been a great partner, and so our engineers really worked very closely with their engineers to ensure that we had a robust implementation and that could withstand the sort of the rigors of everyday bus usage in anger in operation and that so really it was more of it was definitely a three-way thing because we had ourselves the vehicle manufacturer and Stagecoach all involved in how that project in integrating three systems really because you've got the vehicle, our system, and the operator system. So in a lot of ways it was a three-way thing. But I think with the vehicle manufacturer Alexander Dennis, we're very well aligned in terms of processes and the way we work and those sorts of things. And I think this is generally because we have a bit of an automotive background. We're sort of a mix of technologists and automotive people, and so we have that in our makeup. So I think because of that, we've sort of really had automotive processes ingrained in us right from the start again. So it makes it then very easy when we sort of work with a vehicle manufacturer because there's a lot of familiarity with for us with what they do and for them with what we do and the way we work. So it's probably not as difficult as you might think.
Bottom line, you highlight it. You're speaking the common language.
Yeah, absolutely. Yeah. And I think that can sometimes be missed when you've got a company coming from which is doing sort of very deep techie things and they're sort of suddenly, there's a bit of a culture shock, a culture clash between that and automotive. And I think, again, because of our makeup, we didn't really have that.
So you didn't have that. The three systems coming together. That's an impressive feat to make everybody go forward and not go left, right, or backwards. As the three companies come together to integrate three systems, what level of redundancy did you put into these buses? Because you highlighted it many times during this podcast. Operating a bus is not with kit gloves. It's wear and tear and things happen. How much redundancy did you build into these?
A key requirement of the project was that the vehicles had to be level 4. So essentially that we need full redundancy across all safety critical systems for that to be the case. So, and particularly when you think the vehicles running up to 50 miles an hour. So certainly on the motorways they run at 50 miles an hour, and in other places 40 miles per hour. And so we had redundant braking, redundant steering, and then redundant power supplies, and then of course redundancy in the control side and redundant sensing. So it's across the board, which is a key requirement really for these vehicles to run safely on the road.
40 to 50 miles an hour, that's impressive. That's not a small feat. That is a big feat.
Yeah, that's true, and I think that is something that the team are proud of. I'm proud that we achieved that, and we got the safety sign off for it. I think there's still quite a lot of others still trying to get there. So it's we're very pleased with that we were able to achieve that.
Higher speeds, as you know, brings in more potential safety issues. It brings in a higher degree of engineering, and there's a lot of multiple redundancy, different sensors that have to change. That's impressive that you're able to achieve that. I'm a passenger. I go on your bus. Okay, I'm scared. Oh, this is cool. Okay, now I'm bored. Yes, mission accomplished. You're bored, and it's getting you to your journey of where you need to go. What was the feedback from the riders that rode those buses? Did you survey them perhaps before and after the ride? Did you try and gather feedback from them?
Yeah, I mean, I think you captured it there. I think people do. There's usually, and not always, but usually there's a little bit of a nervousness about going on an autonomous bus for the first time. But people do quickly get quite bored and forget that it's driving itself. That's normal. There's very few people. I can't think of any where they've felt more negative about it after they've been on it than. So I think generally speaking, getting these services out there and getting people on them is a real plus, and it's a necessity really to get people on board with. Okay, this is safe. It's we can use these systems, and I think we've had a lot of good feedback as well on overwhelmingly the sort of response has been that the system is as smooth, if not smoother, than a driver. It's appears more sort of stable and less. So that's tended to be the general feeling. So a lot of people just didn't really notice the difference between our driving, and that's absolutely fine. But yeah, there was a significant number thought it was actually smoother, and we do try and make it that way. So yeah, that's partly for comfort of the passengers. We want them to have a good experience. It's not meant to be a roller coaster, and we also. But it's also for fuel savings as well. The smoother the vehicle drives itself, the better the energy consumption, the lower the energy consumption, and so that's really quite an important factor as well. Because again, it's usually with most operators, the operating cost, the fuel consumption is a significant factor, and so. On the CAV fourth route, for example, we measured that and found that we got 7% saving over an equivalent manually driven. Yeah, I know. And that was averaged over a long time, and that was really, I think the thing that impressed me most about that really was the fact that I wouldn't necessarily have expected it on a route like that, because there's a lot of it, as I say, is a constant 50 miles an hour. So you wouldn't necessarily expect that an autonomous system can really do much better than a human driver. But nevertheless, we did get a significant saving. So we hope to be able to repeat that same study over on some of the more sort of stop-start urban routes. And once we've got that data, we'll certainly get that out there too.
7% fuel savings is massive, because if the audience doesn't know, petrol in the UK is very expensive compared to the US. So that 7% goes a very long way.
Yeah. But if you translate that to electric vehicles as well, that's potentially 7% you've got, which you can use for additional range, or maybe if you don't need the additional range, maybe you can make the battery smaller and reduce cost. So, and as I say, the 7% is really just the start. So I think there's a lot of benefits aside from the obvious ones with this technology, and certainly the energy saves is one of them.
And on the electric side, when you reduce the battery size, you're reducing the weight of the vehicle, which helps the motorway and helps the road. So it seems like there's a really great ecosystem of all the efficiency that you're unlocking there. You're clearly going to scale autonomous buses globally. As they scale globally and you have multiple deployments on multiple continents and multiple countries, when do you see we're going to hit a tipping point in public acceptance adoption? This is normal. What are you talking about? That's normal. When are we going to hit that point?
That's a really good question. I think it's not an easy one to give you a precise answer on that. I mean, I think what will happen is that we'll continue to see the smaller scale deployments, perhaps in those scenarios which lend themselves, more easily to an autonomous bus service, and over time, as people. So I expect it will be gradual. I don't suddenly expect that next year the floodgates open and everyone's going to be clamoring to change their manual buses to autonomous. But I do think, we're just at the start now. We're just seeing the interest for actual commercial services to be starting just now, and I think we're going to see a steady increase, I think, year on year. But I think, certainly over the next 5 years, we'll see a transition from, where it is at the moment, with it being highly unusual, to it being really quite normal.
And think about it this way. When you go to an airport and you get on the train that goes in between, there's no driver, and they don't even think about it. You don't think twice about it. You're not like, oh, where is he? You get on there, it's normal. You're irritated when it doesn't show up on time, but when it does, you get on there, and that's normal. Buses for a lot of local municipalities, regional municipalities, are the backbone of public transportation. They've always have been. They will over time. Obviously, the form factors of the buses will change depending on the demand. Jim, in your opinion, what is the future of public transport, and how large of a role over time do you see autonomous buses playing in that vision?
I like to think that buses in general are going to, become more widely used. We're going to see more bus services, and I think autonomous buses are key within that, because it's really the only way that they can be. That can happen. They've got to be made more efficient. They've got to be made more affordable, and I think in order to do that, autonomy is a necessity. But I don't think it's like a suddenly going to be a sudden thing. It's not going to be suddenly, right, all buses are now autonomous. That's not going to be the case at all, I think. And I think what we'll see is a steady uptake in autonomy, and as I say, they'll be used in probably the easier use cases to start with, and there'll be deployments there, and over time, and it will take a long while, and I think there will always be a place for manually driven buses, and I don't think realistically, I don't think any sort of drivers need to be in fear for their livelihoods at the moment, because I think there is going to be plenty of driving, probably more driving jobs than there are drivers for quite some time yet. And so I think it will just be a steady uptake over time that we will see. But I think it will. I think the improvements will be seen, because I think some, as I've said, some of these services which are just currently not viable and can't run, they suddenly become viable and become we'll start to see those being deployed sooner, I think.
Yeah, what you're describing is hybrid networks. That's where things are going. You're going to have human drivers augmenting autonomy, and you're going to have autonomy augmenting human drivers. And that's hybrid network, and that's what's emerging now. Jim, this has been truly fascinating deep dive into all things autonomous buses. So thank you for being our first guest on autonomous buses. I really, really appreciate it. As we look to wrap up this insightful conversation for today, what would you like our listeners to take away with them?
Well, I hope a sort of a sense of optimism for the future. I think this technology can offer all sorts of good things. Not just that people will have more choice in the way they get around and have a more efficient and hopefully smoother, more sustainable service. And also, there's a lot of safety benefits as well, which we haven't spoken so much about that, but these systems will ultimately be a lot safer than the human driven systems. So I hope they'll feel enthusiasm for what we're doing and what we're trying to achieve here.
So I'll sum it up this way, Jim. Autonomy is good for buses. It's going to unlock opportunity, it's going to unlock safety, and it's going to allow individuals that might not have been able to get transportation to get transportation. Today is tomorrow, tomorrow is today. The future is fusion processing. Jim, thank you so much for coming on to SAE Tomorrow Today.
Thank you very much.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we discuss how Integral Power's new battery tech enables longer range, lighter, and more affordable electric vehicles.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.